Hi everyone, in this video we have two inequalities we want to prove using the mean value theorem. So in part A you have to show that for all real values of x and y, the absolute value of sine x minus sine y is less than or equals the absolute value of x minus y. So first you have to create a function of x and create an interval. So suppose that f of x equals sine x in the interval of ab, where ab are any two real numbers such that a less than b. Now you have to check the conditions of the mean value theorem and the given function on the interval we have. So firstly I will check the continuity, and as you know the domain of sine of x and cosine of x is all real numbers. So f is continuous everywhere because it's a periodic function, so it will be continuous on any subinterval, which means that f of x is continuous on the closed interval from a to b. Secondly, you have to check the differentiability of the function, and as you know f prime of x, the derivative of sine x is cosine x, and again the function cosine x, its domain is all real numbers, which means that f prime is differentiable everywhere for the function sine x. So f of x is differentiable on the open interval from a to b. So the two conditions of the mean value theorem satisfied for the given function f of x equals sine x in the closed interval from a to b, which means there is c belongs to ab such that f prime of c equals f of b minus f of a divided by b minus a. Now f prime of c is given, and we found it before. It will be cosine c equals f of b minus f of a, which is sine b minus sine a over b minus a. Our inequality you want to prove has an absolute value, so take absolute value for the both sides. On the left hand side we have cosine or absolute value of cosine c. How to deal with this inequality? As you know, cosine x in general is between -1 and 1, which is the range of the cosine x, and we can write it as absolute value of cosine x less than or equals to 1. So absolute value of cosine x is less than or equals to 1, but absolute value of cosine c is the right hand side, which means that absolute value of sine b minus sine a divided by b minus a is less than or equals to 1. One of the properties of the absolute value, if you have absolute value of a over b, this is equals to absolute value of a divided by absolute value of b. So we can write this one as sine of b minus sine of a. So we distribute the absolute value notation divided by absolute value of b minus a, and this will be less than or equals to 1. Now multiply both sides by b minus a, and multiply here by absolute value of b minus a. Since the absolute value of b minus a is positive, so no need to change the sign of inequality. So it will be the same. Cancel absolute value with absolute value. We'll get absolute value of sine b minus sine a less than or equal absolute value of b minus a. Now change the variables and let b equals x and a equals y. You will get absolute value of sine x minus sine y less than or equal absolute value of x minus y. And this is what we want to prove. So the main idea in the proofs of mean value theorems or Rolle's theorem, you have to create a function, create an interval, then you will continue with the conditions of the mean value theorem, and that's it. Thank you. In part B, you have to show that cosine x is greater than or equals to 1 minus x and less than or equals to 1 plus x for all x greater than or equal to 0 using mean value theorem. So first you have to create a function, and as you see, the function is cosine x, so f of x equal cosine x, and the interval you have to use it must be greater than or equal to 0. Let's say from 0 to a, where a is greater than 0. So you have to check the two conditions of the mean value theorem. First, you have to check the continuity of this function. So firstly, as you see, the function of x is equals to cosine x, and the domain of sine and cosine is all real numbers, which means that cosine x is continuous everywhere. This leads to say that f of x is continuous on any closed interval. So it's continuous in the closed interval from 0 to a. Now the second condition of the mean value theorem is the differentiability. So you have to find f prime of x, and the derivative of cosine is negative sine x. And again, sine x has domain all real numbers, which means minus sine x has domain from negative infinity to infinity. So f prime is defined for any intervals. So f prime or f is differentiable on the open interval from 0 to a. So the two conditions of the mean value theorem satisfied for the function f equals cosine x in the interval from 0 to a. So the conclusion is there is Cn 0a such that f prime of c equals f of a minus f of 0 divided by a minus 0. Now f prime of c is given because f prime of x is minus sine x. So f prime of c is negative sine c equals to f of a, which is cosine a, minus f of 0, which is cosine 0, divided by a minus 0, which is a. So we have minus sine c equals cosine a minus cosine 0 is 1 divided by a. What to do next? You have to take the absolute value for both sides. This is the next step. So take absolute value for the left hand side and the right hand side. So what you will get, absolute value of negative sine c, and one of the properties of the absolute value, that absolute value of negative a equals absolute value of a. So we can write this as absolute value of sine c. And we know that the absolute value of sine x in general is less than or equals to 1. So we have absolute value of sine C is less than or equals to 1. So this means since absolute value of sine C equals absolute value of this rational expression, so we have absolute value of cosine A minus 1 divided by A is less than or equals to 1. One of the properties of absolute value, if we have absolute value of A less than or equals to m, this means that A is greater than or equal negative m less than or equals to m. So if we use this note for this inequality, you will see that cosine A minus 1 over A is greater than or equals to negative 1 and less than or equals to 1. Now multiply A by all terms of this inequality, and since A is greater than 0, because we have the interval from 0 to A, and this means that A is greater than 0, so when you multiply by A, this will not change the sign of inequality, it will be the same. So you have A times negative 1, which is negative A less than or equal, you can cancel A with A, so you will get cosine A minus 1 less than or equal A times 1, which is A. Now if we add 1 to all sides, what you will get? We'll get that plus 1, plus 1, plus 1. So we have 1 minus A less than or equal cosine A less than or equal 1 plus A. Now let A equals x to change the variables. Let A equal x. You will get the inequality what we want to prove. So we have 1 minus x less than or equals to cosine x less than or equal 1 plus x, and that's it. Thank you.